This week in Space Startup News, we cover HyImpulse and their next rocket launch. Then we cover Rocket Factory Augsburg's second stage making its way to Saxford Spaceport in Scotland. A third segment covers Relativity Space testing of its new INR engine. And finally, Astroscale shows off images of its flying around space debris. Let's get started. SR-75 rocket from HyImpulse to launch from Saxford in 2025. HyImpulse has chosen Saxford, the spaceport at the northernmost place of Scotland, for its rocket launches. So why did HyImpulse ditch Saxford for its first launch of the SR-75 rocket and fly from Australia's Southern Launch Gunneeba test range instead? Well, Saxford was not ready for launch at the time HyImpulse was ready to fly. It's not just construction that's needed for a spaceport. There's a whole load of paperwork, certification and licensing which can take years to acquire. Anyway, now it's time for the second launch of HyImpulse's suborbital launcher. Saxford is now ready to support the launch, and the £5 million of funding from the UK Space Agency definitely helps. HyImpulse will be regularly launching their SR-75 from Saxford in future, with their first launch from this spaceport coming up soon. We can't wait to see it. Who will launch first from Saxford? HyImpulse with their SR-75, or Rocket Factory Augsburg and their RFA-1? Speaking of which, let's move on to our second news item. RFA second stage verified, on its way to Saxford. In a post from RFA on X, they state, second stage acceptance campaign completed, our final hot fire test verified, the Helix Vac engine and stage performance for flight, with a 400 plus second runtime and just 1% unburned propellant at engine cutoff. Stage 2 is now on its way to Saxford. Rocket Factory Augsburg, RFA for short, a German commercial launch provider, is on the verge of achieving a historic milestone with its RFA-1 rocket, aiming for the first orbital launch from UK soil. Here's what you need to know. RFA-1 is a commercial space startup serving the small satellite market. It's competing with fellow German space startup HyImpulse, plus other companies like Orbex, PLD Space and more. RFA has completed acceptance testing for its second stage of the RFA-1. The first stage has been at Saxford Spaceport in Scotland for a while, undergoing a hot fire test and other pad tests. Now the second stage is on its way to Scotland for final integration. Saxford Spaceport, located on islands north of mainland Scotland, is gearing up for its historic role. It has already secured 2 of the 3 necessary licenses from the UK's Civil Aviation Authority, one for operating as a spaceport and another for managing the launch range. The third license for airspace control is expected in September. With all parts of the rocket at or shortly to be at the launch pad, and with the final licensing nearly complete, the countdown to Europe's new era in spaceflight is on. We await eagerly the flight of RFA-1 from Saxford. We'll keep you informed as always. Relativity Space tests their INR gas generator. Relativity Space has been busy testing its new INR engine. Recently they tested the gas generator component at the NASA Stennis test stand. The INR gas generator is part of the propulsion system for their Terran-R rocket, designed to be reusable. Here's what you need to know about it. The engine design. The ANR uses a gas generator cycle, which is a type of rocket engine cycle where a small amount of propellant is burned in a gas generator to power the turbopumps that pump the main propellants into the combustion chamber. Let's now talk about the propellants. It runs on methalox, which is technically liquid natural gas or methane, and liquid oxygen. This is a common choice for space startup companies, perhaps because it's more environmentally friendly and cheap. Methane is also easier to handle than other options such as liquid hydrogen and potentially sourced from renewable or Martian resources. And let's finally talk about reusability. The design of the INR and the Terran-R rocket focuses on reusability, with the first stage designed to land downrange after launch, aiming for rapid turnaround times for subsequent launches. Okay, let's move on to our final segment in Space Startup News this week. Astroscale demonstrates advanced fly-around capabilities in space debris mission. Astroscale's ADRAS-J mission is currently in space and has some images to show us. First off, let's break down the mission name. The ADR stands for Active Debris Removal, AS stands for Astroscale, and J means the satellite is assembled, built and operated from the Japanese office. Before you can deorbit space debris, you need to master RPO. This stands for Remote Proximity Operations. It means being able to maneuver around space debris carefully without crashing into them or drifting away. This series of images shows the ADRAS-J satellite moving around the object and photographing it. These steps are necessary before you can attempt to grapple it. The satellite maintained a fixed 50-meter distance from the upper stage and observed it under different lighting conditions. The primary goal of the mission was to assess the condition of the debris, particularly the payload attach fitting, which is critical for future debris removal missions. The data gathered will help the development of ADRAS-J2, which is designed to physically remove the debris from orbit. This mission shows Astroscale's technological advancements in on-orbit servicing and contributes to the broader objective of creating a sustainable space environment by tackling the increasing issue of space debris. Watch my video on Astroscale to get a fuller understanding of the company and its achievements so far. Okay, that's it for this week. Be sure to subscribe to get the latest news on commercial space startups around the globe, from rocket launchers to space stations, orbital tugs, lunar landers and more. If it's a commercial space startup, we cover it. See you soon.